In this lab, we are going to prepare cyclohexene using cyclohexanol and sulfuric acid. So you're going to need all of the glassware for fractional distillation, as well as a separatory funnel. You'll also need a graduated cylinder, cyclohexanol, sulfuric acid, as well as a drying tube, which is going to absorb any vapors from the cyclohexene, because cyclohexene smells pretty awful, so we just want to prevent those fumes from getting out into the lab as much as possible. So what we're really trying to assemble here is what's shown in your handout for this lab. So we're going to recreate this setup. In the first step, I'm going to add 0.074 moles of cyclohexanol and 1.75 milliliters of sulfuric acid to my round bottom flask. So here you can see I've added the appropriate amounts of each reactant to the round bottom flask, so I'm going to swirl it in order to mix the two layers. We could have used phosphoric acid instead of sulfuric acid, but sulfuric acid was more readily available. Next, I'm going to add some boiling stones to my solution so that we don't have overboiling during the gentle reflux or during the fractional distillation steps. So now I've set up the fractional distillation apparatus. This is kind of similar to the biosynthesis of ethanol lab. We have our round bottom flask in a heating mantle. Above the round bottom flask, we have our fractionating column. And remember, that's similar to a condenser, we just have some steel wool in there. Then up above, we have our universal adapter with a thermometer. Then we have our regular condenser going down to the vacuum adapter and the receiving flask. Additionally, we have our drying tube to block any vapors from escaping, because again, cyclohexene is quite smelly. We also hooked up our condenser to the water tap in the hood, and water is going to come in from the bottom of the condenser and out the top of the condenser. So we're going to turn the heat up to start our gentle reflux. So I'm not going to turn it up too high to start. The gentle reflux will allow the two reactants to mix and react with each other. Then we'll increase the temperature to perform the fractional distillation. After some gentle refluxing, I noticed a color change in the solution. It was clear before, but now it's a darker color and the consistency is sludgy. Next, I'm going to increase the temperature on the heating mantle to start the fractional distillation portion of the lab. So again, cyclohexene vapors are going to form, and they're going to travel up the fractionating column, down the condenser, and into the receiving flask. Now remember, the fractionating column is going to allow for better separation of our product from the other elements or reactants in the round bottom flask. So hopefully at the end we'll have mostly cyclohexene, but we'll still do a couple of purifying steps to make sure that all we have in our product is cyclohexene. I'm going to skip ahead a bit to the product collection. After a few minutes, I noticed that the temperature on the thermometer was rising, and I had started to collect some of my product. The boiling point for this product was 68 degrees Celsius to 69 degrees Celsius. This is lower than what I expected for pure cyclohexene, so this tells me that I need to do a few purification steps before I can trust that I have pure cyclohexene. After a few more minutes, I had collected quite a bit more sample, and now I'm just waiting for the reactant solution to decrease to about 1 milliliter. That will tell me that I have collected most of my product from the original reaction. Here is our initial product, and again, it might contain some impurities, so I'm going to perform a wash step. In order to wash our initial product, I'm going to pour the product into a separatory funnel, making sure that the separatory funnel is closed first. You can use a funnel during this part if you're not comfortable pouring directly into the separatory funnel. And then next I'm going to wash this sample with 5 milliliters of water. Next, I'm going to mix the two layers to make sure that I'm really washing my sample well. Again, during this process, you do need to relieve some of the pressure that can build up inside of the separatory funnel. So you can do that by facing the separatory funnel away from you and opening the stopcock briefly. So now we can let the layers settle, and then we will collect our cyclohexene layer. While we're waiting for the layers to settle and separate, let's think about which layer is which. So we have a bottom layer and a top layer, and if we look up the densities of these two different layers, we have an aqueous layer and the density of water is 1 gram per milliliter. We also have a cyclohexene layer, and that density is around 0.9 grams per milliliter. So the cyclohexene should be in the top layer. So here I'm collecting the aqueous layer, and I'm just going to set that aside. And then I'm going to collect the cyclohexene layer, the organic layer. You can also just pour this out of the top of the separatory funnel. You don't necessarily have to collect it from the bottom. Now there could be some water left in this sample, so in the next step I'm going to use a drying agent to remove any leftover water. In fact, you can see some water droplets on the side. Now I'm going to add a little bit of sodium sulfate into my sample. Again, this is a drying agent, and this will collect or grab onto any water that's left in my sample. So I'm going to gently swirl and see if any clumps form, and I can already see a few clumps forming, which means that there was water in my sample. So now I want to add enough sodium sulfate so that it doesn't clump and we actually have some freely floating solid. That will mean that all of the water has separated. Once I'm done adding the drying agent, I'm then going to carefully decant my solution into a round bottom flask. You can also use gravity filtration to separate your liquid from any of the drying agent, but here I'm just going to be very careful in my decanting method. In the next step, we're going to perform a simple distillation in order to collect the cyclohexene. I've set up my simple distillation apparatus. So we have our round bottom flask with our initial sample in a heating mantle. We have our universal adapter connected to a thermometer, and then a condenser, which is then connected to a vacuum adapter. So now I can place a receiving flask under the vacuum adapter, and I'm going to keep track of the boiling point during this step, and that will verify if my product is pure. So here I'm going to place an initial receiving flask underneath the vacuum adapter. This is to catch anything below the expected boiling point of cyclohexene. I'm also going to increase the temperature to start my simple distillation. And after a few minutes, I noticed the temperature rising on the thermometer. So again, if anything collects before the expected boiling point of cyclohexene, that will collect in the initial receiving flask. And then once the temperature hits around 80 degrees Celsius, I'm going to switch out my receiving flask and hopefully only collect cyclohexene. It was around this point that we hit 80 degrees Celsius, so I switched out my initial receiving flask for my actual receiving flask, which I chose an Erlenmeyer flask for. And the temperature range for this collection was 80 degrees Celsius to 82 degrees Celsius. And the expected boiling point of cyclohexene is 83 degrees Celsius. So this seemed like an appropriate boiling point range. Therefore, I can conclude that this is most likely a pretty pure sample of cyclohexene, but we can further verify that by taking an IR spectrum. After a few more minutes, I found that the temperature was starting to increase again and the droplet rate had decreased. So I turned off the heat and I separated the initial round bottom flask from the heating mantle, and I also pulled it off of the distillation setup just to prevent any further heating of the sample. So now I'm just going to collect the last couple of drops here that are coming through, and then I will take an IR spectrum. You can find the mass of the product as well as the IR spectrum on the Canvas page for the Cyclohexene Lab assignment.